Hello everyone, so in today's video lecture, we would now be analyzing a doubly reinforced rectangular beam. So given the figure, we would now be determining the following. So letter A, raw balance or the balance steel ratio. B, nominal strength, and C, design strength. So in this particular figure, we have a breadth of 400 mm, an effective depth of 500 mm. So take note that this is already the effective depth. So meaning it is measured from the top compression fiber up until the centroid of our tensionary bars. So in this problem here, we have tension bars and we also have compression bars. So the concrete strength is 24 megapascal and the steel strength is now for 20 megapascal. Okay, so whenever we are to analyze a doubly reinforced beam, it is actually very similar to a singly reinforced beam. It is just that in doubly reinforced beam, we now have this particular additional force, and that particular additional force is the force due to our compression concrete. So with that, guys, this is now our value. So we still have our 0.85 F prime CAB here at this part, I should say. So once again, this here is the resultant of our compression block, and we have an additional AS prime FS prime here. Okay, so these are the typical steps for analysis for DRRB. So disclaimer that these are just typical. So the first thing that we can do is, in order for us, is for us to check if rho is less than or equal to rho max, or if it is the other way around. So for the value of rho, that is basically the steel ratio, and let us check it with the rho max. Okay, so for rho max here, guys, or for the value of rho and rho max for its comparison, if the value of the actual steel ratio is less than or equal to rho max, meaning that even though we have compression bars here, we would now be analyzing it using SRB only. Okay? So meaning, guys, if for example that the steel ratio of our tension bars is less than or equal to rho max, meaning that we will be solving for it in SRB, meaning that we will be disregarding our compression bars. So that is an option actually. So you can analyze it using DRB or SRB, but according to our code or according to the books, if rho is less than or equal to rho max, we can actually solve for it using SRB. So the answer would almost be the same. So we have slight discrepancy only. But in a situation wherein the steel ratio is now greater than rho max, we have no choice but to analyze our section using DRB. Okay? So once again, if our rho is within the limits, so we can actually solve for it using SRB. So that is one choice. But if the value of rho is now greater than rho max, meaning that we have no choice than to solve for it using DRB. Okay, so suppose that you will now be solving it using doubly reinforced beam. The equation for the nominal moment is now equal to 0.85 F prime C ABW times D minus A over 2 plus AS prime FS prime times D minus D prime. So where did this equation come from? So what I did here was that I have solved for the moment about this location. So from that, guys, if I would now be solving the moment about this location, meaning that for this particular force or for this particular resultant, its lever arm would be this dimension here. And if this is the value of D, and this is the value of A, so this dimension here is the value of A. So meaning that my lever arm here is D minus A over 2. Thus, 0.85 times F prime C times ABW times, of course, the lever arm of D minus A over 2. Okay, so if you can remember from SRB, this is only our equation here. So once again, from SRB, this is only our equation. But this time, since we already have the value of AS prime FS prime, so AS prime FS prime times lever arm, and our lever arm this time, if once again this is the value of D, and this is the value of D prime, so this here is D prime, the distance from this point up until my moment point or my pivot point is equal to D minus D prime. Thus, its lever arm is now equal to D minus D prime. Okay, so with that, guys, you can actually get the moment about any point. So you can get the moment about this point here, anywhere you want. you would still be arriving at the same answer. Okay, so our next issue here is that, so let me just erase this writings here. So our only equation here is that we do not know the value of A. We even do not know the value of fs prime. And of course, the value of A. Okay? So once again, we do not know this particular value. So we do not know this value, and even this value. So before, if you would be solving for the value of A, what you would be doing is just that you would be solving for the forces horizontal, or that compression force is equal to the tension force. And from that, writing your equation for compression is equal to tension, 0.85 FC prime ABW plus ASFS prime is now equal to ASFS. So we still have another issue here. Once again, we do not know the value of A. We also do not know the value of Fs prime. And we also do not know the value of Fs. Okay, so that is now our issue for our equation here. So the next thing that you can do is for you to check if the tension still will yield. So one method of knowing if the tension still will yield is by solving for raw balance. But take note that this is only optional. Okay, so for the raw balance, we have already derived this equation right here from our last video. So we have already derived this. But once again, this is optional. Then, of course, in order for you to solve for this particular figure or particular value, you must know the value of C balanced and Fs prime. So these are now the values of, the equation that you will be making use. So meaning, guys, that, for example, that the value of raw is less than raw balanced, meaning that still will yield, okay? So for the value of raw, if it is greater than raw balance, so for example, that there are plenty of steel rebars greater than raw balanced, meaning that Fs will not yield. So meaning that if Fs will not yield, you will now be making use of this particular equation to our equations on top, okay? Okay, so from that, upon knowing the value of our Fs, so from that, guys, we already know the value of Fs here in this equation. So next up, how can we now solve for the value of Fs prime? So actually, we do not have a direct equation in order for us to know. So what we would be doing at this point is that we would just be assuming if it will yield or not. So it will be up to you as the designer or as the civil engineer, which one you will assume. Just take note that upon assuming if it will yield or not, you must check it first if your assumption is correct. So in this case, I will be assuming, let's say, that it might not yield. So if it will not yield, meaning that the value of Fs prime that I will be using, that is equal to 600 times C minus D prime all over C. So this was already derived before. So once again, Fs prime is equal to 600 times C minus D prime all over C. Okay, so if you would now be substituting this equation to this particular equation, then from that you can now solve for the value of C. So once again, you can now solve for the value of C using this equation. And upon solving for C in this particular equation, the next thing that you will do is using the value of C, you will now be checking if your assumption is correct. So if your assumption is correct, so from that you can now know what the value of Fs prime is. And actually, if you already know the value of Fs prime, then you can now solve for the nominal strength. Since you already know all of these values, so once again, you already know the value of A, you already know the value of Fs prime, and you already have previously solved for the value of Fs. So with that, guys, you can now solve for the value of Mn using this equation. Then after solving for Mn, solve for phi. So after solving for phi, then just multiply it by Mn, then you already have the value of your design strength. Okay, so with that, let us now solve for it in detail. Okay, so as per our steps a while ago, let us check first if we can solve for it using SRB or we are required to solve for this using DRB. Okay, so let us solve for rho. So rho is basically equal to the area of the tension steel divided by BWD. So substituting known values. So since in our figure here we have 5 pieces of diameter 32 rebars. So 5 pieces of diameter 32 rebar. So the area of one rebar is equal to pi over 4 times 32 quantity squared. So divide this by BW of 400 times D of 500. Okay, so looking at the calculator to your left. So let me just turn this on. So this is now once again equal to pi all over, oops, sorry. I should say 5 times pi over 4 times 32 squared divided by 400 times 500. Okay? So solving for this will now give me an answer of 0.02. Okay? So this is now 0. Oops, sorry. So this is once again, apologies. So this is 0.020. Okay? So for the rho max. So for the value of rho max, we actually have two rho maxes. So one is for tension controlled and the other one is the provision of the code. So since it is not indicated in the problem that we will be analyzing this as tension controlled, meaning that we will now be making use of the rho max for the code provision. So this is now equal to 0.85 times f prime c divided by fy times beta 1 times 3 all over 7. So once again, this is a code provision. So substituting known values, this is now equal to 0.85 times f prime c of 24 divided by 420 times betas of 1. So since our f prime c is equal to 24, beta 1 is now equal to 0.85. So times 0.85 times 3 all over 7. So from that, guys, the value of our rho max is now equal to, so looking at the calculator, so 0.85 times 24 divided by 420 times 0.85 times 3 all over 7. So our answer here is 0.0177. And as you can see, guys, since the value of rho, which is this is greater than rho max, meaning that we do not have any choice rather than to solve for this problem using DRB. Okay? So proceeding, since it is now DRB, then we would now be making use of this particular formula. However, our major issue here is that we do not know the values of A, Fs prime, and Fs. Okay, so the first thing that I will do here is for me to solve for rho balance first. Because in that case, I will be hitting two birds with one stone since it is required in the problem what the value of rho balance is. And using rho balance, I can now know and I can now solve if ever the value of Fs would yield. Okay, so from that, guys, once again, I would just solve for the rho balance. So as per indicated here, rho balanced is now equal to 0.85 times f prime c over fy times beta 1 times 600 all over 600 plus fy plus rho prime fs prime all over fy. However, in this situation, guys, we do not know the value of fs prime. So let me just solve for fs prime first. So for fs prime, that is now equal to 600 times c minus d prime all over c. And since we are to talk about balance condition, c balanced is equal to what do you call this? 600 divided by 600 plus fy times the value of d. Okay, so this was already discussed in our previous lecture. So substituting known values for the value for c-bal, this is now equal to 600 divided by 600 plus 420 times d. And d here is the effective depth, 500. Okay? So using the calculator, so this is now equal to, so 600 divided by 600 plus 420 times the value of depth of 500. So meaning that for the C balance, that is now equal to 294.117. Okay, so let me just write them to my next slide since I do not have any space. So again, C balanced, sorry. So again, C balanced is now equal to 294.118. Okay, so from that, guys, I can now solve for my Fs prime for balance condition, that is once again equal to 600 times C minus D prime all over C. So this now equal to 600 times C, and my C is 294.118 minus D prime, and our D prime as per our problem was, so let me just double check. So the D prime in our formula is 60 mm, or in our problem I should say. So that is once again 60 mm. Okay, so going back to our solution, so this is now equal to 60 mm. So this is now divided by 294.118. Okay, so Fs prime is now equal to, so 600 times 294.118 minus 60 divided by 294.118. Okay, so the value of Fs prime is now equal to 563.873 megapascal. Okay, so if we are now to compare, guys, since Fs prime is greater than Fy, since our Fy is 420, meaning, guys, that for our Fs prime, it must be equal to Fy. Since this is the maximum stress that our Fs can handle effectively. Okay, so since our Fs prime is now equal to Fy, so our raw balance is now equal to, so I would just be making use of this particular equation here, and I would just I would just substitute all known values later on. So once again, 0.85 times F prime C divided by Fy times beta 1 times 600 all over 600 plus Fy times, plus rho prime, and rho prime actually is AS prime divided by B sub WD times Fs prime all over Fy. Okay. Okay, so substituting known values here. So raw balanced is now equal to, so 0.85, our F prime C is equal to 24, divided by Fy of 420 times beta 1 of 0.85 times 600 divided by 600 plus 420 plus what is now AS prime. So AS prime, we have two pieces of diameter 20 mm rebars. So 2 times pi over 4 times 20 squared divided by BWD. So our B is 400, I should say. And our D is 500. Okay. So Fs prime divided by Fy, once again, since our compression members have yielded, so this is now equal to Fs prime divided by Fy. Or I should say, since Fs prime is equal to Fy, so meaning, guys, that our Fs prime is also equal to Fy. Thus, this would just simply cancel out. So from that, guys, our raw balance is now equal to, so looking at the calculator to your left, so this is now equal to, so 0.85 times 24 divided by 420 times 0.85 times 600 divided by 600 plus 420 plus 2 times pi over 4 times 20 squared. So sorry, this should be pi, I should say. So times pi all over 4 times 20 squared divided by 400 times 500. So our answer here is now equal to 0.0274. So this is now the value for raw balanced. So from that, guys, looking at our previously solved value for raw, So our row was, so the row actual was 0.020. Okay. So once again, this is 0.020. Okay, as you can see here, 0.020. And as you can see that it is actually less than robal. Okay, so where was that again? So our row balance is equal to 0.027 and our actual row was 0.02. Okay, so from that guys, we can now say that the value of row is actually less than row balanced. So since we have less still than the row balance, meaning that Fs will yield. Thus, Fs is now equal to Fy in our analysis here. Okay? So, next up, since you already know the value of Fs here, which is Fy, let us now solve for Fs prime. But once again, in order for us to solve for Fs prime, what we will be doing is that we will be assuming if it will yield or not. So it will now be up to you. So in this video, I will now assume here that maybe it will not yield. Okay, so I will be assuming that it will not yield. But if ever I am incorrect, then I will just be resolving for it in such a way that it would yield. So once again, guys, for this particular step, we will now be making use of summation forces. Horizontal is equal to 0 or compression is now equal to tension. So looking at our figure on the left once again, so that is now equal to, so what are the compression forces here? So we have these two. So that is now 0.85 times F prime C times A times B sub W plus AS prime Fs prime. This is now equal to AS times, once again guys, for the value of Fs, we have already confirmed earlier that it will yield by computing it with our, by comparing our row to the row balanced. So from that guys, we will now be making use of Fy here. Okay. So next up, so let us now solve for C, but in my assumption here guys, I will be assuming that it will not yield. Okay. So this is my assumption. So I may be wrong, I may be right. So let us check. Okay. So since it will not yield, I will be making use of this particular formula. So Fs prime is equal to 600 times C minus D prime all over C. So from that guys, I will be substituting that value to our equation. Okay. So 0.85 times F prime C times AB, but take note that A once again is also equal to beta 1C. So, since what I will be doing here is that I will be solving for the value of C, I will be writing A in terms of C. Okay? So, this is now equal to beta 1C times B sub W plus AS prime Fs prime. So, for our Fs prime, that is basically 600 times C minus D prime all over C. So this is now equal to ASFY. So as you can see here, we now have only one unknown, which is the value of C. So substituting known values, so 0.85 times F prime C of 24 times beta 1 of 0.85 times C times B of 400 plus AS prime. So let me just compute AS prime here. So looking at the calculator, AS prime is equal to 2 times pi over 4 times 20 squared. Okay. So this is now 200 pi. So 200 pi times 600 times C minus D prime of 60 divided by C. So this is now equal to ASFY. So my AS, so I would just be calculating them here. So for my AS, since I have 5 pieces, so since I have 5 pieces of diameter 32, the AS here is, so 5 times pi over 4 times 32 squared. So my answer here is 1,280 pi. So again, this is 1,280 pi. And as for the compression bars, this is 200 pi. Okay. So once again, this is now equal to 1 to 80 pi times Fy of 420. Okay. So you can now solve for the value of C. So you can actually make use of shift solve command here. However, since in our equation here, this will become quadratic. So meaning by a quadratic formula, there are two possible answers. So in order for me to play safe, I will be transforming our equation here into a quadratic equation, and I will be making use of another calculator procedure, which is mode 5.2. Okay, so simplifying my equation here, so 0.85 times 24 times 0.85 times 400. So this is now 6936C plus, so what is now the next value? So 200 pi. So 200 times 600. So this is now equal to 120,000 pi times C minus 60 all over C. This now equal to, so for the next set of equation here, so 1 to 80 times 420. So this is now equal to 537,600 pi. Okay. So upon simplifying this equation further, so I would be multiplying the whole equation by C in order for this to cancel out. So from that, this is now equal to 6936C squared plus 120,000 pi times C minus 60 is equal to 537. Sorry. So times 537,600 pi. Okay. C, I should say. So simplifying this further, I would now be writing this as 6936 C squared plus 120,000 pi times C. So using FOIL method, so minus, so 120,000 times 60. So this is now equal to 720 or 7.2 million. So let me just count. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Okay. So 7.2 million pi. This is now equal to 537,600 pi C. Okay. Okay, so basically this is our updated equation. So let me just confirm. So 6936, I should say. Okay. So simplifying this further, so this is now equal to, so 6936C squared. And as you can see that we can actually combine these two by transposing this equation to this particular side of our equation. So from that, looking at the calculator, so 120,000 pi minus 537,600. So that is now equal to negative 417,600 pi C minus 7212345 pi. So this is now equal to 0. Okay. So since we already have our quadratic equation, so I will now be making use of mode 5.2 in my calculator. So that is now equal to mode 5, then actually mode 5.4, I should say. So this is once again mode 5.4. 3, I should say mode 5.3. Okay, so what I mean here is that we will be making use of mode 5.3, I should say. Okay, so for mode 5.3, so from that, guys, this is now the value of my A. So once again, this is, oops, sorry. So this is A, this is B, and this is C. So from that, guys, 6936 417, I mean negative, I should say, negative 417,600 pi. So pi then positive or negative 7, 2. So, pi. So, our answer here, so we would now be having two answers. Namely, so for CU1, this is now equal to 205.052 millimeters. Then for C2, we now have negative 15.9 mm. So as you can see here that this is actually impossible since we cannot have a value of a negative value of C. So meaning guys that this is now our value for C. Okay? However, I'm not really sure if that is correct. Because once again, if you can remember earlier that we only have assumed that Fs prime will yield. Okay? So, from that, guys, so since I have assumed earlier that Fs prime will not yield, I should say, so I will be confirming if it has really yielded or not. So from that, Fs prime, once again, is equal to 600 times C minus D prime all over C. Okay, so substituting known values, so 600 times, what is the value of C? That is 205.052 minus D prime of 60 divided by 205.052. So from that, guys, looking at the calculator, so I would be going back to my computer mode or computation mode. So 600 times 205.052 minus 60 divided by 205.052. So as you can see that our Fs or Fs prime is now equal to 424.435 megapascal. And as you can see that it has underwent or it is way past our limit of Fy. So meaning my assumption is actually incorrect. That in my assumption earlier that it will not yield, when we have confirmed it has actually yielded actually. So, once again, wrong assumption. So, wrong assumption, meaning guys that we will be resolving for step 3. So, because for step 4, we would now be confirming your assumption in step 3. So, initially our assumption, Fs prime will not yield, but according to our computation, so computation, Fs prime yielded. So meaning guys, wrong assumption. So meaning guys, we will be recomputing for it. So upon recomputation, so again, summation force is horizontal is equal to 0. Compression is equal to tension. For our compression, this is now equal to 0.85 times F prime C times A times B sub W plus AS prime, Fs prime. But this time, guys, we will now be changing the value of Fs prime as Fy. Because in our computation, we have solved for there that Fs prime will not yield. Okay? But this time, since it has yielded according to our computation, we will now be changing Fs prime to Fy and not to 600 times C minus D prime all over C. Okay? So, going back once again. So, again, that is Fy. And from that, guys, this is now equal to, so for a moment, so this is equal to, sorry. So, this is equal to AS, Fy. Okay, so from that, substituting all known values, so 0.85 times F prime C of 24 times A times BW of 400 plus AS prime. So what was our AS prime once again? So I forgot actually. So I think this is 200 pi. So 200 pi times Fy of 420. So let me just confirm if I am correct. So 2 times pi over 4 times 20 squared. So once again, that is 200 pi. And for our AS, so that is 5 times pi all over 4 times 32 squared. So that is 1280 pi. So this is now equal to 1280 pi times Fy of 420. So as you can see in this equation, we can now solve for the value of A. We can now use the shift solve feature of our calculator. So from that, there's now 0.85 times 24 times alpha x times 400 plus 200 times pi times 420. So this is now equal to 1280 times pi times 420. Okay, so from that shift solve, the value of A is now equal to 174.636. Okay, so for the value of C, so C is basically equal to A over beta 1. So from that, that is now equal to, since beta 1 is equal to 0.85, so I would just be dividing this by 0.85. So from that, this is now equal to 205.454 mm. So let me just confirm if my assumption is now correct. So let us solve for Fs prime. So Fs prime once again is equal to 600 times C minus D prime all over C. So from that, this is now equal to 600 times 205.454 minus 60 divided by 205.454. So from that, guys, so solving for it, so 600. So let me just store my value of C. So shift store to C. Okay. So from that, guys, 600 times C minus D prime of 60 divided by alpha C. This is now equal to 424.78. And once again, as you can see, that is actually greater than 420. So meaning, since my next assumption is that it would yield, meaning that I have now a correct assumption for Fs prime. So let me just confirm that Fs did really yield. So Fs is now equal to 600 times D minus C all over C. So from that, this is now equal to 600 times the our value for D is 500 minus C all over C. So from that, guys, looking at the calculator, so this is now equal to 600 times D minus C. So D is 500 minus alpha C all over C. Okay? So from that, guys, this is now 860. And as you can see, 860 is really greater than 420, meaning that it has really yielded. Okay, so since we already know the value of our Fs prime, the value of A and whatnot, we can now solve for our nominal moment. So listing everything here. So again, the A that we have solved for, or the correct value of A, is now equal to 174.636. Okay, so if you are wondering, what about for this particular value of C? So again, this is actually incorrect because my assumption earlier was incorrect. So meaning, just forget about that and solve for the new one. And the correct assumption is that both of them would yield. Thus, A is now equal to 174.636. Okay, so again, 174.636. Okay, and we have already confirmed that the value of Fs prime is now equal to Fy since it has yielded, and this is now equal to 420 megapascals. So substituting all known values, Mn is now equal to 0.85 times F prime C of 24 times A of 174.636 times BW of 400 times the lever arm of D 500 minus A over 2. Our A is 174.636 divided by 2 plus this particular value here. So AS prime, once again, AS prime as solved for earlier is 200 pi. So plus 200 pi times Fs prime of 420 since Fs prime has yielded. So again, this is 420. So times the lever arm of D of 500 minus D prime of 60. Okay, so solving for the nominal moment, this is now equal to So 0.85 times 24 times 174.636 times 400 times 500 minus 174.636 divided by 2 plus 200 pi times 420 times 500 minus 60. Okay, so our answer here is 704,197,395.9 Newton millimeters. So if you want to convert this into kilonewton meter, just simply divide this by 1 million. Thus, the nominal moment is 704.197 kilonewton meter. Okay, so this is now the value of Mn. Okay, so since aside from the raw balance and the nominal moment, we should solve for, according to the problem, the design strength. So for the design strength, that is basically phi Mn. So since we already know the value of Mn, let us now get the value for phi. So for the value for phi, you can either make use of this table or this table. So take note that you would still be arriving at the same answer regardless of which table you will be using. Or if you do not really want to make use of the table, then just make use of the formulas that is indicated in the code. But take note that those formulas are actually, were actually derived using these tables. Okay, so I would rather make use of this particular table because it is actually easier to solve for the value of Fs than the strain. So again, as you can see here, Fs is now our basis. So again, actually, we have already solved for the value of Fs earlier. So that is 600 times d minus c all over c. So once again, actually, we have already solved for it earlier when we were still confirming. So Fs is now equal to 860 something. So again, for the value of c, it was already stored in my calculator. So solving for Fs here. So Fs once again is equal to 600 times d minus c. D is equal to 500. C is equal to, so actually it is written, or it is actually stored in my calculator as 205. So 205.45 divided by 205.45. Okay. So for the value of Fs, once again, that is equal to, so 600 times 500 minus C divided by C. Oops, sorry. So divided by C. Okay, so once again, this is 860.183. So 860.183 megapascals. So if you want to make use of this particular table, then instead of us having this particular equation, whereas Fs is equal to 600 times d minus c all over c, just make use of strain S is equal to 0.003 times d minus c all over c. So once again, you can make use of this equation. If you do not want to make use of this equation, just take note that if you would be making use of this equation, this is now your table, or the table that you will be referring to. That is in terms of 0.005. But once again, I would rather have this because I just want this to be my basis. Okay, so from that, guys, so since the stress that is being experienced by the steel is 860.183, meaning that for the value of P, it is actually located at this particular point. So it is actually located at this particular point. Okay, so apologies that my line is not really straight. So let me just rewrite that if I can draw it straighter this time. So, well, I actually can't. So assuming that this is now 860.183. So what is now the value for our phi? Okay, so it is either you will be getting the ratio and proportion of it. So from that, guys, phi minus 0.65 is now, divided by 860.183 minus Fy of 420. This is now equal to 0.9 minus 0.65 divided by 1,000 minus 420. Okay, so you can solve for the value of phi there. So from that, phi is now equal to, so looking at the calculator, so 0.9 minus 0.65 divided by 1,000 minus 420. So times 860 minus 420 plus 0.65. So the value of phi is now equal to 0.8397. So this is now the value of our phi. Or you can just use shift solve, or better yet guys, I would now be making use of stat mode. Okay, so if you would be making use of stat mode, so I would be going to mode 3, and I will be selecting for a feature that would give me 2 columns, and that is 2. Okay, so from that guys, I will now assume that, so let me just erase this for a moment, or let me just duplicate this particular table. So for a moment guys. Okay, so once again, our basis Fs is equal to 860 point, what was that again? So 860.183. So 183 megapascal. So once again, it is located at this particular portion. Okay, so looking at the calculator. So for the x, for the values of x, so for the values of x, what I know is the values of Fy and 1000. So once again, for x, let's say that this is y, I will now be typing 420 here and 1000. Okay, so from that, this is now 420 and also 1000. Okay, so for the values of y, for 420, we know that the value of y is 0.65. And for 1000, the value of y is 0.9. So there. So for an Fs equal to 860.183, we do not actually know what the value of y is. So from that, I will now be clearing, before clearing my calculator, I will now type in the values of y, their partners, so 0.65 for 420 and 0.9 for 1000. So clearing it, then going back to stat mode by pressing shift then stat. Then I would now be going to reg or registry. And by 5, then I would now be pressing 5 once again for y caret. So y caret, then I will now type what the value of x is. So the value of x is 860.183. So 860.183 times y caret. So upon pressing equal sign here, it will now solve what the value of y is if x is equal to 860. So equal sign. So again, from that guys, the value of phi is now equal to 0.8397. So it is same as our earlier computation. Okay, so once again, that is now the value for our phi, which is 0.8397. So for the value of PMN, that is basically equal to 0.8397 times what was our MN once again. So for the value of MN, that is 704.197. So times 704.197 kilonewton meter. So from that, the design strength of our concrete is now equal to, so just multiply this by 704.197. So our value for VMN is 591.338 kilonewton meter. So that is now our final answer for this particular problem.